Hi, I'm Wei Ming from class DEEE 2A24. I'm from group GG. I'm in charge of part 1. I will talk about the fundamental principle of counting. First, I will explain to you what is the definition of terms. Event. Event is a collection of outcomes for the experiment. Normally, we using capital letters A, B, C, and so on to represent it. Outcomes is possible result of a probability experiment. Example 1. Given when a coin is tossed, then we need to find the event and outcomes. To solve it, event is coin is tossed, outcome is head or tail. Secondly, why we need to use counting technique? To find probability, we need to know possible outcomes and how many different outcomes are possible. Thirdly, there are two fundamental principles of counting. The first principle is additional principle. The second principle is multiplication principle. I will talk about the first one. That is additional principle of counting. The definition is we let A1, A2, AK be disjoint event with N1, N2, NK become the possible outcomes. The total number of outcomes for event A1 or A2 or AK is N1 plus N2 until AK. The event must be disjoint, so event don't have common outcome, so this principle can be applicable. The example is given a pencil case have 3 pencils and 4 rulers. Find how many selection can user do. To solve it, there are 3 outcomes for pen event, 4 outcomes for ruler events. So there are 3 pen or 4 rulers that user can choose. Total outcome is 3 plus 4 equal to 7 outcomes. The second principle is multiplication principle of counting. The definition is event T1 can perform in M1 ways. Event T2 can perform in M2 ways. 2 successive events can perform in M1 times M2 ways. The example is given when coin is tossed and dice is tossed. Find what is the possible number of outcomes. To solve it, event 1, T1 is coin is tossed. Way 1, M1 is equal to 2 ways, either head or tail. Event 2, T2 equal to die is tossed. Way 2, M2 equal to 6 ways. 1, 2, 3, 4, 5, or 6. So, 2 successive events can perform in M1 times M2 equals to 2 times 6 equal to 12 ways. Why we need to use multiplication principle for counting? The below example, I will tell you why. Given if I have 2 t-shirts and 3 pants, find how many outfits could I wear. To solve it, let 2 t-shirts equals to T1, T2, 3 pants equals to P1, P2, P3. To solve this question, we can use systematic listing and use tree diagram. First, I will use systematic listing. I can choose T1, then choose anyone from 3 pants. So the possible outcome is T1, P1, T1, P2, T1, P3. I also can choose T2, then choose anyone from the 3 pants. So possible outcomes is T2, P1, T2, P2, T2, P3. So the total outcome is T1, P1, T1, P2, T1, P3, T2, P1, T2, P2, T2, P3. Then I will use tree diagram to solve this question. First, I have 2 t-shirts, then I have 3 pants. So my outcome is T1, P1, T1, P2, T1, P3. Then T2, P1, T2, P2, T2, P3. So when I choose T1, I have 3 choices to choose pants. If I choose T2, I also have 3 choices to choose pants. So 2 choice T1, T1, T2 times 3 choice P1, P2, P3. Fifthly, when repetition are permitted in the counting, what should we do? Given if I have to choose a card from 5 cards for 5 times, fine. If the cards chosen must put back, what are the different ways of cards can I put? The second question is, if the card chosen cannot put back, what are the different ways of cards can I put? To solve the first question, the total number of outcomes is 5 times 5 times 5 times 5 times 5. So it is equal to 3125 outcomes. Because after I choose one card, I will put it back. So when I choose one card for second time, I still have 5 tries to choose. For the second question, the total number of outcomes is 5 times 4 times 3 times 2 times 1 equals to 120 outcomes. Because after I chose one card from total number of cards, the total number of cards will decrease by 1. Thank you.